Alright, in contrast, we have a different type of circuit, parallel circuit, which contains multiple paths. Let's take a look. Let's just use our rule. What happens to the current in the circuit? So we have current traveling, and I'll call that I. So you're putting, I don't know, 10 amps of current there. And then when you reach this point right there, that current comes up, and you reach that point. It's like a fork in the road. It's called a junction. Some of the current will travel in that direction. We'll call that I1. And some of the current will go in that direction. We'll call that I2. And current is a conservable quantity because the matter, the amount of charges you put in, has to be equal to the amount of charges that you get out. And let's just not even call that 10. We'll call that I. So what you put in I has to equal the sum of what you get out, I1 plus I2. So we'll reveal the answer. What happens to the current on the right? The sum of the currents through each of the resistors in a parallel circuit equals the current of the battery. So that of the branches, I1 and I2, would have to give you the total current. Now, let's put this away for a moment. You could rewind that and pause it to see it. Now the question is, what happens to voltage? If I start here and travel, I come up through some voltage of the battery, we'll call that V. And then when I take this bottom path, I have to come down through R2. So first of all, V will be equal to R2. We'll take a different path. I probably should have taken the first one to go through 1 first, but we'll deal with it. I'll come up through V, and then I go down through R1, and then back home. So what comes up V must come down V through R1, and what comes up V must come down V through R2. So this will give us another rule for parallel circuits. V, the total voltage, or that of the battery, is V1 equals V2. So in a series circuit, which is one path, current would be king, but in a parallel circuit, voltage is king. So we'll reveal and see what they have to say. Let's move that up too. The voltage across resistors in a parallel circuit is the same. V equals V1 equals V2. As you gain confidence in problem solving, this will become second nature, and we'll write down a list of relevant equations at the end of this chapter, or at the end of the problem solving related to this, that you can refer to, maybe even print out and use. And I'll do that after we solve these parallel circuit problems. These are the easy ones. You're going to do great. So if we look here, there's a set of rules. First of all, current breaks, and then because current here is V over R, we end up with an equation for total resistance is 1 over R. So again, voltage everywhere is the same. That's an important equation. Current everywhere splits. And this is a new and unusual equation that we're going to apply to find the total resistance. What is the total resistance of this circuit? The equation that we're going to apply to find the total resistance is on the previous page.